Bismillahirrahmanirrahim. Assalamu alaikum. Dear student, welcome to this course, Basic Physical Chemistry. Today is our first online lecture about distillation and concept of azeotropic mixture. I am Dr.Naila Khalid, Chemistry Department, Cust, Kohar. The contents of our present session will be distillation and its various types. It's basically a purification technique, and then we will discuss about the azeotropic mixture, its speciality, its chemistry, and its separation of its components. First of all, you should have a concept of a mixture of or a solution. You know, a solution is a mixture of two or more than two components. The mixture are of two types on the basis of the boiling point of on the basis of their composition, on the basis of their boiling point of the component. If the boiling point of the component is different from each other in the same mixture, each component has its own boiling point. This is a simple mixture. But azeotrope is another type of mixture in which the boiling point of each component is not different from each other. Whole mixture has single boiling point. So this is special type of mixture. This is a simple mixture in which components have their own boiling points. First of all, we will discuss a technique which is used to separate components of a simple mixture. This is a technique which is known as distillation. This distillation is a technique to separate various components of a solution on the basis of their boiling point. So here is the distillation assembly. You can see over here distillation flask, and you can take over here the mixture, simple mixture, heat it up, low boiling solvent will vaporize, pass through it, condense, and then collected in this collecting funnel. Very simple distillation technique which is used. This is also known as purification techniques. You can use it for purification of liquids, but it is only possible if the components has its own boiling point. You can separate each component on the basis of its boiling point. Various applications of this distillation technique are desalination of seawater. You can carry out desalination of seawater. You can remove salt from the seawater by using this distillation, and you can also use it in distilled beverages, fractional distillation of petroleum, and cyanogenic distillation. And another important application of distillation is the purification of water in your lab. That distilled water is obtained. This is distillation assembly specialized for water. And here is the heating system. This is specialized for water purification. Now, types of distillation. There are various types of distillation on the basis of your requirement, on the basis of the nature of the components. Simple, fractional, vacuum, steam, azeotropic. First of all, fractional distillation. This type of distillation is different from simple distillation by the presence of this fractionating column. This is specialized for those mixture in which there are multiple components, and all components are different from each other on their boiling point. So this fractionating column is basically designed to separate each component, each fraction. So that is why it is known as fractional distillation. Now, vacuum distillation. This is another distillation technique. The only addition you can see over here, this is creating vacuum, and creation of vacuum will lower the boiling point of the component. So this is specially designed for those mixtures in which the components can be destroyed on their boiling point. There is chance of their decomposition at their boiling point, so we cannot separate these components on their own boiling point, but we create vacuum so that we can collect them at lower temperature than their actual boiling point. So this technique is steam distillation. This is, you can say, here is the steam is producing, water is heated, steam is passed through the mixture, and then the volatile component is, first of all, volatile component is converted into vapors and then condensed and then collected. This is specialized for those mixtures which can be decomposed upon direct heating. So we are not heating it directly, but we are heating it through steam. So this is steam distillation. Now come to this point that distillation and each and every type of distillation which we have discussed earlier is specialized for those mixture in which there is difference of boiling point. But azeotrope is a special type of mixture. This azeotrope, it is special type of mixture because it has its own boiling point, only single boiling point, and its composition is also fixed. The two parameters of azeotrope are important: its fixed boiling point and its fixed position. And you can see its fixed position, a composition, and its fixed boiling point. So you cannot separate each component on the basis of their boiling point, because now the boiling point of the whole mixture is the single one. So if you boil it, you can see that the vapors and liquids both contain both components, are all the components. So this concept was first developed by John Waite and Richard William Harriman. That is why this concept of azeotrope is known as azeotropy, is based on single boiling point and fixed composition. In contrast to azeotrope, zeotrope is a mixture of liquid that do not form azeotrope under any conditions. Under any conditions, it will not show you single boiling point at a fixed composition. It will show different boiling point for the different components. Now we will discuss various types of azeotropes. You can categorize azeotropes on various bases. On the basis of number of constituents, there may be binary or ternary, two or more than two components, heterogeneous or homogeneous, positive or negative. So you can say that heterogeneous are those mixture, those azeotropes in which the liquids are partially miscible with each other. However, the homogeneous are those in which the liquids are totally miscible with each other. The positive uh, azeotropes are those which are also known as minimum boiling azeotropes. These are those azeotropes in which the components have the boiling point of the whole mixture is lower than all the components, the boiling point of all the components. Whereas the negative azeotrope is the maximum boiling azeotrope, are those azeotropes in which the boiling point of the azeotrope is higher than the boiling points of the whole components. Now we will discuss various aspects, various properties of the azeotropic solutions. These are binary solutions with fixed composition. You can see that these are real solutions. Ideal solution never be azeotropic. Ideal solutions, in ideal solution there is no association. However, in azeotropic solution there is some association that leads to fixed composition and fixed and single boiling point. Fractional distillation is used for the separation of various components of the mixture only if there is difference in their boiling point, but this cannot be achieved for the azeotropic mixture. Separation of azeotropic mixture can't be achieved by fractional distillation, because the mole fraction of the liquid phase and the vapor phase are not equal. That is why you cannot use it. And how you can separate it, this is another story. Now, low boiling azeotropic solution. These are the examples of low boiling azeotropic solutions, which are also known as positive azeotrope. Water and ethanol system, 95% water and ethanol system. Very strong hydrogen bonding even between water and ethanol molecules. So another positive azeotrope is benzene and ethanol, 67.7%. Water and pyridine and acetic acid and toluene all have the boiling point which is lower than their component. For example, this one, water boils at 100 degrees centigrade. Separately, ethanol at 78.37. If we have 95% ethanol, the whole mixture will boil at 78.15 and so on. Now the examples of high boiling azeotropic solutions, which are also known as negative azeotropes. This is an example: water and nitric acid, chloroform and acetone and chloroform. In these systems, you can see that water which boil at 100 degrees centigrade, nitric acid at 83 degrees centigrade. But if you have a fixed composition, 68% nitric acid in water, then it will boil at 125.5 degrees centigrade, which is very high as compared to both water and nitric acid. So all this applies to these two examples. Now we will discuss about the positive and negative azeotropes. These are the two curves. You can say the positive azeotrope. Here is the methanol, and this methanol is mixed with chloroform. Here is, you can say, temperature and mole fraction. Mole fraction means the composition of the mixture. So as the mixture composition is changing, you can see that the boiling point of the methanol is decreasing. And at the point where the fixed composition, at this fixed composition, the boiling point of the mixture is single one. However, the chloroform has its own boiling point. So this is a positive azeotrope in which the boiling point of azeotrope is lower than the boiling point. So this figure shows the relationship between mole fraction and the pressure. This azeotrope, which is positive azeotrope, has higher vapor pressure and lower boiling point. And opposite in the case of negative azeotrope. This is an example of high boiling, maximum boiling azeotrope, negative azeotrope. Here you can see the pure water, and here pure formic acid. Water, formic acid. Water has this boiling point, formic acid has this boiling point. As you are going to increase the concentration of formic acid, boiling point is increasing. And at a point, then you will observe that the mixture has a single boiling point. This point is known as azeotrope, and this is higher than the both of the component. So that is why it is known as negative azeotrope. Now we will discuss that how you will carry out the separation of these mixtures, because there is separation of these components, as these components are not different from each other. On the basis of their boiling point, you cannot carry out simple distillation, even fractional distillation or any type of distillation. Only you can carry out azeotropic distillation. This type of distillation is a specially designed technique in which we add a third component in the azeotropic mixture. This third component will alter the boiling point in such a way that it can be separated, right? If you have added third component in this, and you have an addition of Dean and Stark apparatus. This is Dean and Stark apparatus. Remember from here and this one, this is Dean and Stark apparatus, specially designed. When you heat it up, the vapors comes here, and one of the component condense, like water is one of the component. It is condensed in this way, and it is collected over here, and this is for the cooling of the azeotrope, which condense here. So azeotropic distillation usually refers to specific technique of adding another component to generate a new low boiling azeotrope that is heterogeneous, producing two immiscible phases. उनके दरमियान separation कराते हैं, then it will give you a different a successful separation of the azeotropic component. Summary of this session: we have discussed about distillation, its various types, azeotropic solutions, zeotropic solutions, types of azeotropes, and how we can separate various components of the azeotropic mixture. That's the end.